Hi, we have visiting us Deborah Seligsohn. She's a scholar and researcher at the University of California, San Diego, and has been interested in and working on issues of power plants, air pollution for quite a while, and is a very fascinating. You've had a chance to really see China and India up close. So a lot of people in India look at China to see trends and what they've done, because just some years back, India and China were very similar in terms of their installed power plant capacity, for example. And then China took off in the 90s mainly. And some of that growth was due to smaller plants, sometimes dirtier power plants, which were very provincial, if not local, in terms of jurisdiction, ownership, and control. And now China's been on a spree in the last few years of cleaning up, not just because of air pollution concerns or its global concerns, but for other reasons as well. And so, India-China comparisons, what are some of your insights, or is it that India is going to end up following the same path as China? Just share any thoughts you have on India and China from a power plants, coal power plants perspective.
So, India and China are often compared on air pollution, and they're pretty similar at this point in terms of the amount of pollution exposure per capita. The difference is that India is on a rising curve where it's increasing every year, and China now has 5 years of a decreasing curve where the amount of exposure is actually going down. So China actually in the last few years has started to do things, especially in the power sector, that are effectively cleaning up. In terms of power itself, I mean, China has more than 4 times the installed capacity of India, and it supplies electricity to its entire population, and actually had solved that problem basically at some point in the 90s in terms of connectivity and in terms of access. But in terms of reducing shortages, it's pretty much solved that recently. Although that's been one of these things where it went up and down for years, where they would overbuild and solve the supply problem, then they would cut off building new plants and the supply problem would reemerge. But at this point, it seems like it's pretty much in balance, especially because the total demand isn't increasing that fast anymore. The economy is slowing down a bit, but also there's this shift from industry to services that means that the amount of electricity you need per unit GDP,
or the growth especially,
is tapering. So that's a big change in China, whereas in India, you're still very much in a growth mode. It's clear that the amount of installed capacity in India is not actually sufficient to meet the actual demand if everybody had access and the supply were 24/7. So there's a clear demand for more power in India. And so whatever regulations are done for pollution need to take into account not just the amount of power plants in India now, but the amount that are likely to be in India in the future.
And that's an area where a lot of people have said renewables have a great future, not just ahead of them, but it started to grow dramatically.
Right.
But that has not been to a level that we stop coal or even measurably make a dent in the coal trajectory that's envisaged in the coming few years. And so coal is not going away in any time soon. And so the question is, how do we make it as clean as possible?
Right.
And so India has put out some much more stringent than before norms that are due to go into effect 2017 for power plant emissions.
Right.
Tell us about them. Are they tough, very tough, doable? What are reactions, comparisons, things like that?
So the norms for existing power plants, I would say, are a little looser than is the case elsewhere in the world if we're comparing to China, the US, or Europe. But there's a substantial improvement over the previous. So India previously has only had a norm for particulate matter, not for sulfur dioxide or NOx or mercury. And all 3 of those come in with the new standards. And the important thing to remember, because in India the last couple of years everybody has gotten on this, it's all about PM 2.5 bandwagon, is that the source of PM 2.5 is not just particulate itself.
The high ash, the coal ash.
The ash.
Yeah.
It's also the sulfur dioxide and the nitrogen oxides that lead to PM 2.5. Basically, they're emitted as gases, but then there's a chemical reaction in the atmosphere and they turn into particulates. They turn into sulfates and nitrates. And so what you're breathing in is PM 2.5 from many sources, some of which started as particles themselves and some of which started as gases. So when you want to address PM 2.5, you actually have to address all of the pollution sources, not just the stuff that starts as particulate. So this new sulfur regulation is really important. For new plants, the Indian standard will be the equivalent of the US and European standards and the Chinese standard as of 2011. But the Chinese are actually bringing in a new standard that will be by far the strictest in the world. Moreover, unlike the US, certainly, the Chinese are forcing retrofitting on everybody. There's nobody that's going to be allowed to emit at the old levels.
So no grandfathering.
No grandfathering. So what the Chinese are doing, which I think is what kind of makes sense in India, is you close down the oldest, dirtiest plants, especially because, as you mentioned, they tend to be smaller, and you put good equipment on the new large plants. Chinese plants are very large. The typical unit is 600 megawatts. But new plants in India are coming in often at 660 or 800. So these large, efficient units are sort of the way everybody's been going.
So there's two dimensions of norms. One is, are they doable, or the cost? And anything's doable at the cost and effort. And the second is just measuring it, monitoring it, compliance, and these sorts of things. So can you talk a little about any of these dimensions?
So on the doable question, all of the technology we're talking about is 1970s technology. I mean, some of it may have been perfected over time, but we're not talking about modern technology. We're not even, for the most part, talking about things that are under patent. It's readily available on the market.
Suppliers.
Yeah, lots and lots of suppliers.
Indian suppliers?
Not now, because India has never required anything but what are called ESPs, electrostatic precipitators, right? So this is for the particulate. For sulfur, what you want is equipment called flue gas desulfurization, FGDs, or commonly called scrubbers. Those are readily available from multiple international suppliers, US, Europe, Japan, Korea, China, but India is currently installing the first two it has ever had, so it just doesn't have a history of producing these. For nitrogen oxides, the most common used is something called SCR, and I'm going to forget what the initials stand for, but
Selective catalytic reducers, I think.
Yeah, something like that. It's definitely a catalyst.
Yes.
And again, there are lots of suppliers around the world, but it's never been done in India. I understand, talking to the power sector here, that they need to do a little bit of experimentation and testing on how it will work with Indian coal.
Because of the ash?
Because of the ash. So the SCR has to go in at the beginning of the process before they remove the ash. So they have to figure out how the catalyst and
Because you need it warm.
You need it very hot. So they need to figure out how the catalyst is going to work and what the sort of how much deterioration they'll get within the system and things like that. So there's definitely a little work they need to do. Some of the power companies have started to do that, so that's a very good sign. For the scrubbers, I don't think there's anything they need to do. They just need to start using
Sulfur
it.
clearly is something that needs to be tackled very quickly. And even though people believe India is low sulfur coal, on average, that is partly negated because of the low calorific value of the coal. You need more coal throughput. So there is still, you couldn't just say that Indian coal is low sulfur and therefore we don't need equipment. Is that correct?
That's correct. And unfortunately, what you just said is what had been said in India for many, many years, without a lot of attention paid to measuring what the actual sulfur dioxide was coming out of the power plants. Now that people are actually measuring that, I think there is a growing understanding that first of all, Indian coal, I would call more medium sulfur than low sulfur. It's not as low as the Powder River in the US, which is the lowest sulfur coal in the world. And there's this heat content problem. What ultimately matters is how much you're burning.
The throughput.
Yeah.
So, in terms of sensors or sort of detecting it, is there any insights from China? Because it seems that the tighter your spec is, the harder it is to actually tell what's going on. Any thoughts or suggestions in that front?
Yeah, so the Chinese have shown that you can do this very quickly. I mean, they had, at the time they started, more than double the number of coal-fired power plants that India has currently, and they installed this continuous emissions monitoring equipment throughout the country in about 3 years. So you can get it on quickly, you can sort of connect everybody up. It took them about that long to connect it. What they've also shown is to start getting results, you need to connect it at all levels, local, provincial, national. You can't just leave it up to your local bureaus.
Yeah.
Because what the problem in China, and there are some suggestions that you may have similar problems here, is that the local government may prefer to just collect the fines rather than enforce the controls, right? There's this
it's income generating cost of doing business, yeah.
Well, and for the local government, it may become a source of income.
Okay.
So what you really need to do is make sure that it's being watched at multiple levels. So getting the whole system connected and integrated. India is definitely in the process of implementing SEMS. It seems to be being done state by state. They're not all, as far as I can tell, using a unified system, which is a problem because then it makes it much more difficult to integrate to the national level. Each state is sending out its specs to
So that was its requirements. It was viewed as a local/state issue.
Yeah. So I would suggest with SEMS that it would be better if they think about an integrated national system. The other thing they should think about early is transparency. This information can be made available to the public. It's now
in real time.
In real time, there are now. Well, when I checked a few months ago, there were 40 power stations in China that were already putting their data online publicly. There are probably more now. So you can put it online publicly. The connection to your local pollution control board can easily also be put on the web. So especially in India with your vibrant free press and NGOs that are interested, it would be very, very useful to have that data available to the public because one of the big gaps in India is that the pollution control boards are very understaffed. Now,
can you give some numbers or something?
Yeah, so for example, the Delhi Pollution Control Board has 200 staff, of which most of them are support staff. There are 24 engineers. The state of Bihar, which is one of the largest state-level governments in the world, population of the state, has 75 staff. A state with a lot of staff is like Maharashtra with a couple thousand. If you compare that, the US EPA has 18,000 staff, and we have about the equivalent at state and local level in the US. It's actually hard to add up in the US because of our federal system. China has probably about the same number of total staff in the country as the US, so somewhere around 30,000, 40,000. Fewer at the national level than the US has, and many more at the state and local level. So I went to Yantai, which is a medium-sized city in China, 6.5 million people, and they had 4,500 people working for their pollution control board equivalent. And they also have, theirs are called environmental protection bureaus, and they get down to the very local level. So they have people at the city level, and then within the city, they have people working at the district level, right? Whereas in India, you have a state pollution control board, and then you typically, in a big state like Maharashtra or Gujarat with a lot of industry, you have a couple of field offices. And that's the most that you have anywhere in India. City governments do have some environmental workers, but they're typically working on sewage and solid waste. They're not working on air pollution. So one of the big problems this leads to is, yes, you need to put continuous emissions monitoring equipment on that they can watch at headquarters, but you also need inspectors to go out and make sure that it's being run correctly, that there are no bypasses going on, that
No fake data.
Yeah, so in China...
So let's assume people don't want to go fake. Let's assume the intent is correct.
Right.
At a technical level, are there issues just of the quality of the sensors or calibration, something like that?
So that's an interesting thing that I've discovered in India, is that typically these power plants are only calibrating every 6 months. The US EPA thinks you need to calibrate every week. The Chinese are calibrating every 2 weeks. So I don't know if the equipment is exactly the same, but I'm a little surprised by the 6 month.
So that's certainly something someone needs to study immediately and figure out. Another point is, so we're going to, it appears there will be a mix of time frames with which different plants do or don't put in retrofit equipment or choose different paths for new equipment, new plants coming up. Now, a lot of your older plants, not the very old, which the government wants to shut down, for example. There's some 34 or 38 gigawatts that are talked of being shut down. But there'll be some that need not be or could not be shut down, practically speaking. But if they're older, they may not have such a long life ahead of them. Mm-hmm. So does it make sense to do them, or what's in it for them to be sure that they get their money back, that they'll actually get that investment in clean technology back? What are some things, or just that isn't the current norm meant to be a tariff petition, that you had a tariff that was approved before, and now because you're complying with the statutory requirement, you're allowed to charge more for being compliant. Right. Is that a long drawn out process? Could we simplify it? What are some thoughts?
So one of the things in terms of the timing is when the regulation came in, so it was announced in December last year, due to be implemented by December 8th, 2017. That is incredibly tight. It's hard to imagine that even if everybody started working really hard on day one, that you could get every power plant that needed to retrofit equipment up and running within 2 years, because they need to first study, they need to do a design for their individual power plant, they need to do a procurement, but as you mentioned, they need a new approved tariff to be able to afford the new equipment, so that adds a step. But even if we ignore that step, you need to do a design, you need to do a procurement, you need to actually get the equipment delivered on site, and then you need to do a scheduled shutdown for the installation. It's going to be 60 to 90 days that the power plant has to be closed while an FGD is installed and an SCR. If you do them both together, that's going to save you time in the long run, but it's probably going to be more like 90 days. So within any area, the Electricity Regulatory Commission is going to have to schedule these shutdowns so that they're not all shut down at the same time, right? And my understanding in India is they actually have to apply to the regulator for permission to shut down. So you would expect that it's going to be a couple years, even if everybody had the equipment, for this scheduling of shutdown. So if you figure that design and procurement takes at least a year, that you're talking at least 3 years, if not more, to get the whole country deployed. The Chinese deployed about 80% of the country in about 3 years. But there are reasons why their system is simpler than the Indian system. And that's what you were raising about the tariff. So in India right now, every plant has to apply independently for a tariff. As you mentioned, they have legal justification for asking for a higher tariff because it's a legally imposed cost on them. But they still separately need to apply for a new tariff for each unit in each plant. In China, the government simply said, you will get X amount more money for running your scrubber, running your SCR, and it's a different amount for each piece of equipment. So the power plants didn't need to think about the costs beyond that. They could just look for the least cost supplier and go ahead and install the equipment. In terms of shutdowns, India's in a good place right now because at least in terms of the amount of power that's being purchased by the distribution companies, the discoms, there's excess power in the system. Now, I don't view that as real surplus because there's a lot of members of the public that are not getting the electricity that they want. But in terms of what the discoms are willing to buy, apparently there's 24 gigawatts of power sitting idle. So if you could get that online, you easily should be able to balance it out to do a nice scheduled shutdown of different plants to do this retrofit. But it still would take several years. So it seems clear, and certainly what the power companies are asking for, is that the government put out a schedule for realistic installation of the equipment so that, I mean, it seems obvious they're not going to make it by December. But the question I have is, right now it seems like the government's going to criticize the companies in December for not meeting it, and then they'll negotiate a schedule. Why not sit down now
Have that
and plan out a logical
plan,
plan for the next several years? The companies will, of course, ask for lots more years, but you could reasonably think about what a logical number of years are. And I don't think it has to be many, many. I think in 3 or 4 years you could get it done.
And you could also maybe target bang for buck, the ones
the
that
big
are
ones
egregious
first.
or bigger, yes.
And or ones closer to large habitation and things like that. Yeah, absolutely. But these new standards should be done. I mean, the amount of sulfur being emitted right now is really high, and it's been growing very, very fast in India. And when people look at the NASA satellite data on sulfur, a lot of it is coming from the power sector. Because remember, power in India is almost 70% of coal use. That's different than China, where it's only 50%. And even though it's a lower percentage in China, just attacking the power sector, they've been able to make significant inroads in terms of cutting pollution.
So it's palpable.
Yeah.
So that's in some ways good news because there are only a few hundred power plants across India compared to, we don't have as much heating requirement as China does.
Right.
You talked about this push towards PM as catches everyone's attention, especially Delhi and certain cities. But combustion seems to lead to much more PM 2.5, while different numbers on what is air pollution, or even PM, there are different measures. PM 2.5, the finer grain. There's even PM 0.1, or PM 10, which is easier to measure, and has historically been measured across India. Are there some insights or lessons or warnings in just how we compile numbers?
Well, so in India, you're now measuring PM 2.5 in all the major cities, and that's important, and that's what you should be measuring. In smaller cities, they're still not measuring it, and you're also not measuring out away from the cities a lot of the pollutants, which is why the sulfur numbers get missed and the sulfur contribution to PM 2.5, because in the power plants in India are not right in the city.
Now they're being built further away.
They're further away, but that sulfur dioxide moves and it becomes PM 2.5 in the cities. So I think there's that issue. But in terms of the measurement, yeah, if you're measuring PM 10, because there's so much dust in India, there's a lot of construction dust, a lot of road dust, that PM 10 number is going to be really high. So it makes it difficult to compare cities that have PM 10 and PM 2.5 as their measures. I don't think any of this is absolutely critical, because the point is it's all too high and it all should be cut, and there are reasonable things that should be done. I mean, things like covering construction sites, things like fixing roads, they're important. The other thing is, while the PM 2.5 causes more health problems than the PM 10, if you fix a road, not only do you get rid of the dust that is annoying to people, you also ensure that your vehicles are performing better. So and the vehicles are a big source of PM 2.5, both as particulate and as the NOx that turns into particulate in the air. So all of these things are important. The reason I've been focusing on the power sector is you get a lot of bang for your buck. It's a very concentrated, large source of pollution. So if you can do something in these few hundred power plants around the country, you can actually make a dent, and you may be able to bend the curve and start reducing pollution rather than seeing it continue.
Clearly, there's a lot that can be done and is being worked on, and we need multi-stakeholder engagement to have actionable, achievable targets and mechanisms. There's always the elephant in the room, cost.
Right.
And I think consumers understand that better quality, whether it's air or any product, costs a little more. Is this a very large number when you normalize it, for example, in rupees per kilowatt hour, or is it only 10, 20 paise or something like that?
Right.
I think that may be something citizens and consumers are willing to absorb.
Right. So right now in India, there's a lot of debate about what the costs are going to be. But that has a lot to do with the fact that there are no local suppliers, and most of the companies have not done a great deal of research with international suppliers. If we look at the Chinese case, they wound up giving the power plants essentially the equivalent of about 15 pesa additional for adding the sulfur controls, and then about half that in addition for adding the nitrogen controls. So we're not talking about huge numbers. And if we consider that renewables are really important and they tend to cost a little more, it's going to be useful to actually add to the coal price to encourage renewables. So it has kind of multiple benefits in the system. The key thing is for the power plants to be incentivized, you need to first of all make it easy for them to get a new tariff. And secondly, I think you should change the dispatch rules, so that the dispatch is what order power plants are brought onto the system based on demand. And what India has right now is renewables get put on the system first, which makes total sense.
But fuel costs.
Right. But then among coal plants, the cheapest ones go first. And if you changed it, as they've already done in China, to make the greenest ones go on first, that if you don't have your equipment up and running, you don't get added to the grid, you would really make a huge difference, and you would incentivize firms to add the equipment early rather than later because they would get on the grid sooner.
And we ask for run.
Right.
Not just the capital investment, but the operation.
Yeah, because if they don't run, they don't make money.
Yeah. And so it may be important, just thinking out loud, that you may have a hybrid system, because that may be very expensive, or at least perceived to be expensive. So that's a process, and I think a discussion that we will need to continue at another day, because there's a lot that you've shared with us. It's not something you and I can answer as scholars.
I mean, the thing is, it's not that expensive. The running costs of a scrubber is essentially 1% of the energy in the facility. So the costs are not out of this world. It's quite doable, and most of the rest of the world has done it, and it's great that India now has these new standards that should really help with a major problem, air pollution.
Fantastic. Thank you for joining us and sharing some of your insights, and we look forward to chatting with you when you're visiting.